Today I'm going to look at how you graph lines versus how you graph parabolas based on their equations, because all shapes that we're going to study will have a nice form to put the equation in. And when that equation is in that form, then all of the numbers in the equation will mean something to us, and it will make it much easier to graph. So we've already done lines. So for example, if we have a line and it's in the form y equals 2/3 x plus 1. We already know that the two numbers that are in there, we have 2/3 and we have 1, that these two numbers mean something directly to my graph. So let's start with the 1. The 1 is what we consider the y-intercept. Okay, so let me just write that there. That's my y-intercept. So that means that I just go either, if it's positive I would go up, and if it's negative I would go down. So that's where it crosses the y-axis. This other number here is my slope. So from my y-intercept it tells me to rise 2 and run 3. And I can connect these 2 points using my line feature there. So let's look back again at what I'm looking at here. So again, if I've got this equation and it's already in this nice form, now our form has a name. Our form is the slope, oops, go back a second, the slope intercept form, because if I have the number right there, that's my slope, and the number right there is my intercept. So we see it in y equals mx plus b, or slope intercept form. Just write that slope intercept form. Alright, and again I can see that these numbers here will be directly related to points on my graph. So the 1 is where I started, and that was up 1. And the 2/3 meant I would rise 2 and run 3 to get to my next point. So there's a slope of 2/3. Now, I'm going to put two things over here and we'll actually compare them. I'm going to put the equation of the parabola, and I'm going to start with one that is already in the nice form, and I'm going to show you what its graph looks like so that you can see the connection here. Okay? And I'll just go ahead and plot some points. 1, 2, 3, 4, 5. And then 1, 2, 3, and down 1, 2, 3, 4. Okay, so again, I already knew, oops, the shape I was looking for. Now, I'm not as good at drawing these parabolas. So, I did this by, well, part of it by looking at this. The rest of it, I'll have to show you how we do this, because this is already part of what we know. We're just kind of tying several things in together. The new part's right here, though. Okay? If you look at this lowest point on my graph, it's called a vertex. And it has the ordered pair 3, -4. And if you look back at my equation that's in what we would consider the nice form right here, there is a 3 and there is a 4. Here, oops, that's a 3, -4. Just fix that. So there is a 3 and a -4, which is even better. So we call this form that I put the parabola in, we're going to call it vertex form. So let me write that under there, vertex form. And it would say that y is some number out front. Now in our class, at our level, this number, we're not going to use it to study our graph. We're only going to use these other numbers to study our graph. In the next course, we will use the number in front, this a. Okay, so it's, the form is y equals some number out front, the quantity x minus h squared plus k. Just like over here, if we have mx plus b, any letters that are not X or Y would be numbers. The M and the B represent numbers that relate to the graph. Well, here, any letters that are not X and Y are related to numbers that have something to do with my graph. So again, A we'll discuss next in the next course. But the other two here, H and K, those are the vertex. So it would be the opposite of whatever number you have right here. And it would be the same as this number right here. So this is my vertex form. As we go up higher in math, we'll derive why that's the vertex form. At this level, we don't have quite enough math, so we have to just kind of compare our equation to what the graph looks like. So we have, if you look back at our equation here, y equals 1 times the quantity x minus 3, that quantity squared minus 4, then we have a vertex of the opposite of this number, which would be 3, and the same as this number, which would be negative 4. Now, 1 point on a parabola is not enough to graph them. So what you will always have to do is, if your parabola has x-intercepts right here, then we would need to find them. So let's do that next, so that you can see how I got a complete graph over there. My x-intercepts are where you let y equal 0. So I've got 0 equals 1 times the quantity x minus 3 squared minus 4. So I don't really need the 1 here. And if you look at the whole equation, I only have one copy of x, because I need to solve for x, and then I can get my x-intercepts. So I'm going to move the 4 over, and I'll just kind of remove the 1, because it's not important for us to solving this. Okay, and then to get rid of the square, I have to square root both sides. But when I put the square root there, remember, this is really an absolute value, and I would remove the absolute value and put the two different directions, the right and the left, over here. So I end up with plus or minus 2 must be what x minus 3 is. Or in other words, x, if I move the 3 over, is 3 plus or minus 2. But I can put those two answers together because they're like numbers. So I either have 3 plus 2, which is 5, or I have 3 minus 2, which is 1. So again, these are my two x-intercepts, so at 1 here and at 5. We will also be finding the y-intercept later as well, but 3 points at this point is how you would graph a parabola. And the key to our vertex form is this vertex right here. That's what I'm finding. So there's an introduction to the way that our equation for lines shows a map of how to graph it, and that will be true as well for our parabolas. If you put the parabola, or we don't call the equation the parabola, we call the equation a quadratic. So if you put your quadratic in this form, which we'll call vertex form, then it gives me a starting point for graphing my vertex of my parabola.